let's elaborate more about how a hybrid car works. Moreover, how does the hybrid system conserve energy and use them more efficiently? Okay. Maybe if you talk to anyone, most of them would say the reason a hybrid vehicle save fuel is because it runs on electricity. That's not true. Not entirely true, at least. Actually, what happens is the hybrid vehicles consist of two engines, and out of the two engines, only one of the engine is actually making power. That is the internal combustion engine. It is converting power from petroleum into mechanical energy, into movements. As for the electric engine, well, it's not making anything out of the petrol you put in the tank. So what is the function of the electric engine or the hybrid powertrain? Right. The actual function of the hybrid powertrain is to scavenge wasted energy. Alright, in a conventional car, you waste a lot of energy. What causes this is because on a car, there is no linear, or there is no fixed speed. You need to run at varying speed. It's a stop and go, and all this will cause waste of energy. That's why, in a sense, an electric train is much more energy efficient than a car can ever be. Okay, so what does the hybrid powertrain do? One of the important components in a hybrid powertrain is the battery pack. The battery pack acts as a reservoir, as a buffer, where it can store all the possibly wasted energy. Right. And then the next important component of a hybrid powertrain is the generator or the alternator, which oftentimes also acts as the motor, as the electric motor that moves the car. Now, the generator acts similar like the internal combustion engine. It is a power converter. While the internal combustion engines convert chemical energy into mechanical energy, the alternator or the generator converts mechanical energy into electricity, which are then stored in the hybrid battery packs. Okay, what sort of wasted energy are we talking about here? Okay, a conventional car wastes energy in a lot of ways. One, when you are decelerating or braking. Why? Because it needs a lot of energy to accelerate. As you can see, acceleration itself, the units for acceleration is always times -2. Yeah, while speed is times -1. So accelerating generally takes almost double the power than to sustain speed. Okay, so once we have used all the energy to accelerate, let's say to 60 kilometers per hour, having to brake or slow down, how do we do that? We press the brakes or we decelerate. On a conventional car, when you decelerate, this actually puts pressure on the clutch plate, on the internal parts of the engines, which then converts the movement the mechanical energy into heat through frictions, which slows the car down. This is true for the friction brakes as well on conventional car. So what happens in a hybrid? Okay, in a hybrid car, it uses regenerative braking. It has it has two main advantages. Okay, one is what is the original aim by the engineers, by the designers of hybrid. It converts the movement, the mechanical energy, into electricity instead of wasting it as heat and noise and so on. It does this via the generator by reversing the polarity or putting resistance in the coils. Okay. And instead of wasting all the initial energy that you put to accelerate, it recovers some of that energy and stores it in the hybrid battery packs. Right. And another advantage of regen braking for me is the wear and tear. It will reduce wear on the brake pads because you don't rely on friction brakes as much as you do on a conventional car, right? So how else? Now this is a little bit specific on the Toyota Prius. The Toyota Prius uses an Atkinson cycle engine. So is Atkinson cycle engine better than the normal auto cycle engine used on conventional cars? Well, yes and no. Atkinson cycle engine have a very narrow efficiency range, unlike an auto cycle engine which has more usable power throughout the rev range. This is one of the reason why Atkinson cycle are not used on conventional cars. Normally Atkinson cycle engines are used to power electric generators or any other applications that requires only one flat RPMs, such as, like I said, a generator, and it can stay at that RPM for prolonged period and have the maximum efficiency an internal combustion engine can have, which is roughly about 35% at most with our current technology and material. Okay. An Atkinson cycle most probably wouldn't work well on a conventional car, but it works on a hybrid because the hybrid have an electric motor which assists the lower rev range deficits of an Atkinson cycle engine. This also means that an engine in a hybrid in a hybrid vehicle such as the Prius C will always run at its most efficient RPM, and this translates to efficient energy use and better fuel consumption, right? Yes, when you're idling, right? To keep the journey smooth, to keep wear and tear down, a conventional car needs to idle. And not only that, having to start and restart also uses more fuel, so it is more inefficient. And when you're idling, you are wasting a lot of energy. They have been studying, they have been designing a few innovations to remedy this, like some of the MIVAC engine by Mitsubishi shuts down 2 cylinders when they are idling, so that it can cut down on the unneeded fuel consumption, unneeded fuel burn, which might work, might not, we don't know. Okay. What happens is when a car idles at 1000 RPM, okay, if you look at dyno charts on cars, at RPM a car might be horsepower. You don't need 10 or 15 horsepower to power the auxiliaries like your air conditioning, your alternators, your radio, and so on. So what happens to the rest of the horsepower produced? Well, it is basically wasted. Wasted movement turned into heat, noise, etc. And again, not only that, the reason why your car is not making as much torque when it's idling compared to at higher revs, at certain rev range, is because it is not running at its most efficient RPMs. Internal combustion engine tends to do that. They are not efficient when they are not under load. All internal combustion engines do that. Right. So unless you're under load, cruising on the highway, your car is at most probably are only 10, 11, 12, 13% efficient. So you're not burning fuel correctly, you're wasting fuel. You're not getting the most out of the petrol that you're burning inside your engine. So idling will cause the conventional car to use more fuel. How about hybrids? Right. So if you've driven a hybrid before, I mean a true hybrid like the Toyota Prius, not to dismiss the Honda Insight and so on. Honda Insight is not a true hybrid in a sense. It's a gasoline engine with an integrated motor assist. So it's a different story there. But if you drove a Prius, you'd realize that when you're idling or when you're crawling in traffic, the engine will suddenly switch on when the battery drops to a certain level, and when the engine starts, it will rev pretty high, not like a conventional car. You can actually feel and hear the engine running. There's no tachometer, so from the sound of the engine, I'd roughly say around 2000 or 3000 RPMs perhaps, and I'm pretty sure that is where the engine starts to become efficient. Otherwise it wouldn't do that. So what happens when the engine starts, when you're crawling in traffic or when you're idling, the engine will immediately start and run at its most efficient RPM, meaning that it burns fuel as efficient as it could, producing good horsepower. And why don't they do this on a conventional vehicle? Because on a conventional vehicle, when you're idling or crawling in traffic, you don't need that much horsepower. Well, this is where a hybrid powertrain excel, because it can save that unused energy, that unused horsepower, that unused power that is being produced in the hybrid battery pack to be used later. So on a hybrid vehicle, when you're standing still in traffic jams like this, or when you're crawling at walking speeds, the engine will sometimes start. It will be very efficient when it starts, and it will generate power and stores it in the hybrid battery pack. When it has maybe 30-40% charge, the engine stops and you'll be moving on saved energy. Yeah. This way the engines don't need to run with no loads where it is not efficient, and the engines don't have to run as long as a conventional car. The advantages are, you save fuel, you're more energy efficient, and less wear and tear on engine parts, which is good. Okay, so I guess that's about it. Well, I believe there's more, but I just can't think of any right now, and we're still crawling in traffic. Yep. Okay, we're crawling in traffic, and the instantaneous fuel consumption indicator is right now showing right. I hope you can see that. 30.1 kilometers to the liter. That's 3.3 liters to 100 kilometers. So if any of your friends, or maybe you yourself, are skeptics about fuel efficiency of the hybrid car, well, don't be. Seriously, because there's a reason they make hybrids, because they are much more efficient, and efficiency doesn't only translate into better fuel consumption, it also translates into a much cleaner car. Okay, and since petrol is a non-renewable resource, using less of it means you're saving the planet. And maybe you don't care about the planet, but at least you're doing something, and keep that in mind and you'll feel very good.